Hello and welcome to yet another Trino community broadcast. This time I'm reporting not from Europe, but from quarantine in Canada. And we're in the in-between time of events between the Canadian Thanksgiving and the US Thanksgiving. And there's also another big, great event coming next week, but you'll find out a lot more about all of those things very shortly. Today, of course, I'm again joined by my co-host and favorite leader, Brian. And we also have Andrew and Derek as guests today from Pravega. So we'll have a lot of interesting things happening. So let's roll, Brian.
Awesome. Yeah. So really excited about this one coming up. I don't know if as a relatively baby project, and I'm not sure how old it is internally. Maybe I'll ask you that in a second, Derek. But it's relatively new, I think, to me and a couple other people out there, and really excited to talk about it because it's coming in and on the heels and kind of challenging a couple of these like powerhouses that we know in the industry, like Kafka and Pulsar, and kind of challenging some of the existing event streaming capabilities and adding in new features and just doing things a little bit more, I guess, scalable and differently. So we're gonna jump a lot more into that here in a little bit. But first, I'd like to kind of introduce and kind of get to know a little better some of our guests. So Derek, I reached out to you. I don't know, was it like 3 months ago or so? Like talking about Pravega and figuring out if we had some overlap in the Trino Pravega area. Was that about the right timeline?
Yeah, I think so. It's been a minute now. Yeah.
Yeah. And what do you do? Like, where's Pravega come from and what do you do on it? And also, how old is Pravega? I'm kind of curious about that as well.
Yeah. Pravega is about 5 years old.
Okay.
Started, I guess, as an internal Dell project, needing to sort of refactor aspects of existing, event buses or, distributed communication platforms.
Very
so
cool.
I work as the community manager of Pravega. We've got quite a number of people working on Pravega or technologies surrounding Pravega. So there's quite a lot of us over at Dell working in this space.
And it was open source from day one, or how did this work? How did this all come up, I guess?
Yeah, pretty much. I think, to be successful in the streaming space, Dell realized they needed to make this an open source project. Kind of like you were saying, I think streaming is relatively new. I started seeing a lot of streaming around 2010 as people tried to achieve like what they termed internet scale. So there was a lot of use of ActiveMQ or RabbitMQ.
Yeah.
Maybe around 2016 to 2018 is when I think Kafka really started blowing up and people really started looking to adopt Kafka. I know I started adopting Kafka around 2016 at a company. And I think Pravega dates back to about 2017. Its 0.1 release was open source.
Okay.
So, we're releasing 0.10 now. So we've had, I guess, 10 major releases. We're probably closer to 1.0 than ever. We keep debating when that should happen.
That's always an issue, right? Yeah. It's always like, when does this become like the one?
Right.
Yeah, I always find that funny when projects are like very old, very mature, running in production all over the place, but then some humble engineer decides it's a 0.0 something version.
Yeah. Okay, well, thanks for that little kind of intro to yourself and Pravega, Derek. Let's hop over to Andrew. Andrew, have you been in Pravega since day one, or are you relatively new to the project, or when did you get involved?
Yeah, sure. I've been at Dell EMC for like 12 years, mostly working on like cloud storage. I actually have not worked on Pravega proper. I've just kind of been loosely associated with it, working on some things around it, like integration with Trino, and more just like, what can we do now that the data is in Pravega? What can we do to query it and do useful things with it? So that's been probably the past year or two. So I've gotten familiar with Pravega. I've used it, but not as a hands-on coding, adding features kind of way. So yeah, it's definitely been cool learning about it.
Well, great. We're definitely gonna. So we have a lot of folks on here that kind of come from a lot of different backgrounds, right? That some of them are just analysts or data scientists that use Trino. Other ones are the engineers that set it up, and some are pretty familiar with batch, but maybe less familiar with streaming and real time. And so I think when we get into the concept here in a little bit, we're going to kind of take a step back and kind of talk about what is an event, and and all these different things. What is the concept of streaming? I think we'll get into a really cool conversation there. But before we jump right into that, I'm going to do a slightly different take on our advertisement, and we typically just do kind of a Starburst ad for Galaxy. But instead, I am going to do a really quick talk about an event we have coming up, which Manfred earlier alluded to, called Trino Summit. And I mentioned this a couple times. I've been really horrible about actually broadcasting and getting this out into the world, but it's coming up later this month now that I've been super late on advertising and marketing this well enough. But it is coming up October 21st, October 22nd. We have a lot of really cool talks coming up. Let me just quickly highlight a couple of the speakers. So we have, for instance, Ryan Blue from Tabular, Akshat Nair. He spoke on a Trino meetup a while back. He's engineering manager from DoorDash. Also Satya Bora. Of course, we got the typical trio: Martine, Dane, and David. All the co-creators of Trino there. And then we have folks from Robinhood, Netflix, LinkedIn, Electronic Arts, Stream Native, and we also have StarTree. Founder Zhang Fu talking about Pinot a little bit. So quite an array of folks talking at this year's event. And we have talks, anything from state of Trino as the normal, as well as how to get fast results with Iceberg, and a lot of caching happening at Netflix, affinity schedule caching. So a lot of interesting ways to speed up your queries and make things go super fast. So really looking forward to this event. I have a little treat for everybody at the beginning of the summit. So look forward to that. It has music and all sorts of crazy jams that will be coming your way from Commander Bun Bun. And we're going to be doing prizes, handouts, all sorts of fun stuff.
So Brian, that all sounds awesome, but how do I get there and how do I register?
Yes.
What's it going to cost me?
So it's not going to cost you anything. Good question there. You can register for free. We will have the details for that in the show notes. But basically, if you just go to starburst.io/info/Trino Summit, and then you go to the register section here. And again, that link is going to be in the show notes. I know it's not the easiest one. And then go to this sign up page here. You just fill out your information, and we'll basically get you a link that will come back, and we'll have your little link to fill out your information and join our little event session. So that'll be the 21st, 22nd. And again, really looking forward to that. We tried to make it good enough times for that, so that people in Europe and people in the US could all enjoy it. But, that's never super easy to do. And unfortunately, it'll be a slightly unfortunate timing for especially people in APAC. So we really do apologize, but we will be actually having more of these types of events as we scale up to in multiple regions as well. So
but you can attend it from the comfort of your living room or couch, right?
Yep, at whatever time it is for you at the same time. Yes, and this is all virtual, is all live. So so it will be none of this pre-recorded stuff or anything like that. We will be reporting everything live. So all really exciting stuff. Awesome. Yeah. So anything else I missed there, Manfred? Before I move on into our little
we'll
news
be there,
segment?
right?
Yeah, actually, yeah. So Manfred and I will both be there. Manfred's going to be kind of in the background. I'm going to be, as per my usual status quo, just hanging out in the front, blabbing my mouth off, and getting everybody stoked and excited about Trino. So really excited about this. And with that, let's move on to news. So Manfred, what is going on with the release? Which release are we on anyway? 363.
363. The numbers are rising up. We'll get to the one release a day soon, right? Like 365, 366 coming shortly.
Yep, totally.
But yeah, the 363 came out recently, and one of the cool things that happened is Trino has this event listener system where basically it can broadcast events out or query completions and all sorts of like information around that it's processing basically. And now someone actually in the community wrote an event listener plugin. And what that allows you to do is you can basically configure that, and then the events like query completion, what the query was, who initiated, is basically that payload is sent via HTTP to a receiving end, and you can like have that whatever system you want, and then you can track basically what's going on in Trino, and that's the first community implementation of that, and that's very cool.
Nice.
So, and then, you can do audit or whatever else, any analysis, depending on how you capture the data then at the other end, which is really nice. Other things that got done is insert and override for S3 back tables was implemented. We got a few new types, supports in different connectors. So scaled float in the Elasticsearch connector, the tuple type in the Cassandra connector, as well as the time type in the MySQL connector. So all of those are new, as well as the last one, datetime offset in the SQL server. So lots of kind of that, like, small but very useful changes, because, if you use one of those systems and you have a table where there is that data type and it doesn't work, then you have to futz around with workarounds like mapping it to varchar and then like casting it and stuff. That's all painful, right?
Yeah, and that was one of the workarounds that I did when the Elasticsearch side, right? Where you had that thing where you could just set that property and say, okay, anything that's, from this property below is now officially JSON, and we just return it to you as the JSON blob.
Yeah, and that's great as a workaround and fix, but ultimately you suffer in terms of like, you have to cast and you have to like understand, your users have to understand that they need to do that, and it makes it slower and all that pain. So these little changes make a big difference for those users that are affected. So that's great.
Yeah, totally.
Another thing that happened, again, if you look in the general section of the release notes, a whole bunch of little miscellaneous performance fixes and memory usage improvements got in again, which always is great, right? Like we're just inching closer and closer to performance that no one else can touch. So that's really cool. There was some regressions recently with the show roles SQL command that had some downstream problems, but that was fixed now. So if you're on 362, you should definitely upgrade. A similar regression was fixed again as well on the explain analyze. The estimates display kind of was busted for a little bit. That's got fixed. And then one last thing that had numerous fixes was Parquet files. There was a bunch of improvements for Parquet file reading, and that affects the Hive and the Iceberg connector. So
yeah, there's been a lot we've had coming in for Parquet specifically. I feel like it's become a much more popular use case. And before, for those that don't know the history of the context, like we like Dane in particular, like he rewrote the orc serializer, deserializer, and all that code there from scratch for Trino, and was it like the big focus was on orc and making sure orc was performant. And then over time, Parquet got added in, but it wasn't up to par with basically the orc performance. And so more recently, there's been a lot of aim to fix, especially these nested kind of field type of use cases that come around Parquet. It's like the one reason why you use Parquet and not orc, at least in my personal view. I'm a huge orc fan. So, but yeah, so like, the nested thing is a super important use case, and we're adding a lot more performance enhancements around, how that gets queried and parsed and everything.
Yeah. For the longest time, orc was way ahead in performance because it had that custom written reader and writer, and Parquet would just use the Hive one, which was slow. Now it's pretty even. Like Parquet can basically touch orc now. So that's very useful because as it stands, a lot of people use Parquet as the default file format. So makes a big difference for those users. So it's cool. Cool. And that's 363. And of course, we're working on 364 already, but that will have to wait for next time.
For next time. All right. Well, shall we move on to the concept of the week?
Let's do it.
All right. So now we are at the concept of the week. And as we kind of mentioned in the intro, this is all talking Pravega. So Derek, I wanted to make sure that we got everybody who is not up to snuff and up to speed on a lot of this, event streaming stuff. Like first, let's just have a quick kind of discussion around events and streams and what are all these abstractions and how are they useful and how do we represent them?
Yeah, sure. I mean, going back to your release 363, you've already mentioned events, right? So
yeah,
your webhook handler, I guess it is.
Yep.
It sounded like you're emitting user events out of Trino.
It's
like if I submit a
queries.
My query's executed.
Yep.
Yeah.
Exactly.
Right. So
that's a great tie-in. Yeah.
Yeah. I mean, we have all kinds of systems emit these kind of useful tidbits of information. Audit trailing maybe is what your new event feature sounds like, but sometimes these events are basically like state transfers between distributed systems, and they're critical components of business logic as state is communicated around various systems in an enterprise.
Yeah.
So I mean, just continuing with your little Trino events, you could hook our webhook handler, our webhook receiver, up to your HTTP event broadcaster. We could write these events to Pravega and then turn around and use Trino to query Trino's audit trail.
Nice.
There's all kinds of, I guess, guarantees you need to give yourself if you're using events to develop a system. You need ordering typically. If you can't guarantee ordering, you need idempotence. There's quite a lot of complexity that develops as you're dealing with failures. You need like infinite retries. If you're doing that, you need like, I guess, subsequent queues to put your retries into. It just there's quite a lot to it. When it comes to your systems getting more traffic and all being event driven, now you're having to scale these middlemen that are delivering your events around. And that's, I guess, where Pravega comes in, is to provide a reasonable base for scaling some kind of an event passing system.
So in the slide here, I see it says server, sensor, etc. events. What are some of the practical things of events that are sent? Like, is it like IoT events, like light switch on and off, like even those kind of things, or?
Yeah, sure. It could be anything. I mean, I tend to think more about, from my background is in telecommunications, internet service providers. So there, our events are much more critical. Without events, we couldn't scale the telephone system. Yeah. And in that world, like, you can't lose an event or else, you have some kind of system failure. So
there's also like Uber, right?
Right.
That's a lot of events coming in, and every person with their cell phone, right?
Yeah, for sure. I mean, maybe with some farm sensors, maybe with farm sensors or like GPS pings, you can tolerate some loss. Yeah. In other systems, you can't. So there's there's different maybe bars of different thresholds, I guess, of service.
Criticality, yeah.
Right. There you go.
Cool.
So what makes then, so we get is a stream basically just a bunch of events, or is a stream something more than just like, I get a bag of events, and right. And you were saying something about ordering idempotence, that's basically where you want to make sure that if I do something over and over again, like the same result occurs, right? So like what's special about a stream that's not just like maybe just a bag of events?
Well, in Pravega, a stream truly is a sequence of bytes. So, there are, I guess, protocol prefixes in most messages or most events. In Pravega, though, we represent a stream as just a sequence of bytes. We call that the segment.
Okay.
We tack on a small length header, but that's about it. We don't, other message platforms, they provide you a message object, and you pack your headers into their headers section. You pack your data into their data section. Pravega, we just take your data as you hand it to us. We tack on little length header, and that's all there is to it. So, so under, if we're looking at this sort of head to tail right here with events going into it, on disk, this is truly just a stream of bytes. And if we're looking at the first event there, E1, it's prefixed by a little length header. E2 as well.
Is it me, or did we lose Derek a little bit?
I think oh, there he is.
I'm popping in and out. Okay, I'm back. Well, so when the client's streaming this stuff back, the client's actually responsible for separating the events in that regard. So this allows us to do some novel things around continuous data, such as like multimedia or video streams.
Cool.
We're not in other systems. You're typically like, irrespective of multimedia framing, you're cutting the data up into packets and shoving those into messages, and then on the other end, you're like retrieving messages and pulling your data out of packets and then like reconcatenating. Well, in Pravega, your data just stays concatenated as you sent it in.
It's literally just storing it, right? It's like,
right. So we have a byte stream API where we don't put those length headers in, and we just store your bytes directly. So the bytes you send us are the bytes we write to disk, and then you can read those bytes back without any event framing.
Very cool. So we, this is kind of one idealistic view of events, right? But I know that this kind of, if this were the actual true picture, right? Your events are very linear, and you have, one event after the other. It's a very, nice little queue there. Then that might be an easier problem to solve. But Pravega noticed that this isn't the right way to model events or streams, right? I think from what particularly I looked at one of the other engineers, Flavio's kind of presentation on this, and he likes to see events like this almost. You see these kind of things happening at the same time, and things get bigger, things get smaller, and the demands are constantly changing as time goes on. And I think many of us that are listening to this and watch that, we're like, oh yeah, that makes much more sense, right? This is really how the real world works.
Sure. Well, yeah, I mean, under previous systems, maybe if we're thinking about ActiveMQ or whatever, these were like more monolithic single system.
Yeah.
Right. So if your pipe needed to get bigger to support more throughput, you had to like enlarge in the entire pipe or scale up. Right. So, systems obviously like fluctuate in their throughput. So as we're all wanting to, I guess, build our businesses and make more revenue. As we do that, we'll see more use and require more load.
Yep.
So we need a good way to scale our systems as load increases or decreases.
Yeah.
And I guess that's where Pravega comes in. Is we don't really see it on this diagram yet, but we're stacking basically segments.
I can go. I'll skip straight to it. There you go.
Okay.
So
yeah, I mean there you can see where we're sort of like splitting and merging segments as time goes on. Now this is using I guess our event API. So we have routing keys here on the.
We'll hop into that too. I just wanted to kind of give you some reference to keep going on with what you were saying.
For sure.
Yeah.
So this is kind of counterintuitive in the sense that like the smaller the rectangles get, the more throughput we're handling.
Mm-hmm.
But you can kind of see segment 1 splits into segment 2 and segment 3. Segment 0 splits into segment 5 and segment 4, and then as traffic is diminishing, segment 2 and segment 5 merge into segment 6.
Yeah. So I wanted to just give you that visual to speak to real fast, and we'll hop more into detail in the segments here in a second. But I just wanted to throw you the phone.
So right under the covers, that would be what's happening in a fluctuating stream like this. Is you'd be increasing and decreasing the number of segments that you're appending to in parallel. Keys may or may not be used to order individual events on the receiver side.
So if we, because one thing I like to see is like if we zoom in, let's look at one particular point in time where let's say this load increase happens, and we have pretty much like 3 events here happening simultaneously. In the next split, let's say about roughly, you have E25, E22, E23. Those 3 are happening roughly about the same time. So about this load increase here, at least in this picture, if we were drawing a vertical line across these, as you go across in time, you're going to want to have maybe at least 3 segments here. Whereas, as we go where the load drops, you only have, one kind of, if we're drawing the vertical line again and we're going across, you're only having one event coming in at a time. And that's where we kind of draw that correlation with the picture that we just saw, where we have all the little rectangles. Is anytime we draw a vertical rectangle through any of those segments, when they're split, that's those, you could basically write to all 3, an event to each of those segments at a time. And you're being able to handle that, parallelly and also basically being able to essentially handle the load at that point. So that's, just wanted to, some of these drawings may be a little abstract for those that are not as familiar, but yeah, I just wanted to, make that connection there for anybody who was confused by the square drawing before.
Sure. Yeah. And the concept, I guess, is to add more boxes to the problem and scale out the solution rather than upgrade to beefier boxes.
Yep.
I mean, that's pretty well understood these days. Yeah, but 15, 20 years ago, we were building larger boxes each time, right? So.
Yep. So I want to dive in a little bit more to you mentioned it before. You said, essentially segments are just, in Pravega anyways, it's a bunch of bytes. So you said, really, it just ends up being you get a message in, let's say from, or a message or an event that has all this byte data. How do you decide how do you split it up, and how is that tracked? Once you do split it up into these different segments, I'd like to know kind of, how these segments kind of become segments and ultimately get tracked and, are coming from that event.
Yeah, sure. Well, I guess the number of segments is based on scaling policies. Pravega can auto scale. You can manually scale as well. You could tell it like, stream, you're fixed at 5 segments. Okay, now stream, you're scaling up to 10 segments. Okay, now you're scaling back down to 3 segments, right? You can do that manually, but also you can set scaling policies, and then the system will measure throughputs and scale automatically for you, adding and removing segments as needed for whatever your scaling policy is.
And there's a direct correlation to how many readers and writers you have based on how many segments there are, or that's also kind of configurable as well.
There can be that. Yeah, there's a callback in the API, so you can receive sort of we call them epochs when we're changing the segment, the time steps where segments split or merge. At those points, you can get back how many segments are in play now, and then in your orchestration, you could spin up or tear down writers or readers. Okay, very cool. So that is possible. We could use more automation there for sure, but the system is built, to enable those use cases.
Awesome.
Very cool. Then so I guess similar to Kafka or any number of other systems, there's this concept of a routing key, right? So if I'm sending events and I'm as the sender, I need to guarantee order, I can indicate that order by routing key. So I could also maybe not use routing keys if ordering isn't a concern of mine. Then
all just goes.
Then my events go into a random segment. Now there will be some, I guess, stickiness, or I don't know what the best word is, but we'll stick with a random segment for a while, and then we'll switch to another random segment.
If you don't care about routing keys or order at that point, does Pravega kind of take more into account the load of a particular segment or kind of hotspots, that kind of thing, based on node traffic or something else, or is there something else that you're more concerned about?
I don't know that we're doing proper load balancing yet in that sense. Like maybe it's possible just through the chaos to get a hot segment.
Okay.
But it's more, the stochastic, random, the nature of like picking a random segment and then sticking with that segment for a little while.
And that's almost always good enough anyways. It's just those weird use cases,
Yeah. And so you could monitor, I guess, all of that and do, provide that to yourself for sure.
Yeah. Or do you have customers or users that are doing a lot of these kind of like really crazy stuff, or is it still pretty like, just use kind of what's out of the box, or they're using routing keys specifically and scaling, do kind of auto scaling just out of the box stuff?
Yeah, I think we're pretty good out of the box. There's obviously a lot of use cases, we're getting a lot of requirements for what we're seeing.
Okay.
So we're constantly, improving the system. Our next round of improvements actually are going to be kind of dedicated to observability and debuggability. So
cool.
So
it's very useful.
Out. Yeah, for sure.
Awesome.
Yeah. So let's see where we at in our little.
Yeah. So I was going to say, like, this is kind of like a rehash of the old events, kind of the events picture that we had before, and now scale down and scale up in Pravega is, I guess, looking like you have a whole bunch of these segments that you're writing a bunch of bytes to, and then as let's say auto scaling kicks in and realizes that there's a lot of traffic essentially coming in, and you need to start doing that further segmentation. You need to add new segments. Then you basically reset the routing keys and basically add new segments, a new set of segments that will scale up for you. And then when the load kind of diminishes again, you go back to this too. So I think that's roughly what I'm seeing here, but I don't know if there's anything else that kind of goes into that I'm missing.
Well, one distinction is maybe we use routing key space regions instead of sharding, right? So other systems will sort of they'll like modulo a number based on the number of nodes in a cluster, and that will pick the assigned cluster, the assigned cluster node. In Pravega, though, we split up the routing key space regions. Typically, we think of it as like between 0 and 1.
Okay. And
then different regions of that number line will be assigned to individual segments.
Okay.
So if there's I guess regions in that number line can be hotter than other regions depending on keyed traffic. If I've got a lot of traffic on a particular key, then obviously that segment's going to be hotter than other keys. So we may, so it's not an equal division. In typically in sharded systems, it's like an equal division of the space, and then you're relying again on like stochastics. But in Pravega, we may give one segment more of the routing key space because that routing key space is quieter, I guess is one way to say it.
That makes sense. So if we go back to this picture again, so the 0 to 1, could you give me like a maybe a practical example of like what maps to that space? Because it sounds like basically we're saying you take some original space like geolocation or something like that, and you basically normalize it to a 0 to 1 on this, at least for this picture. And then
you could think of maybe like a keyed by account number. Right. So then my account number may hash to like 075. Maybe my account number 12. You send that through our floating point hashing algorithm, and you get back 0.5. Well, every time for account 12, you get back 0.5.
Okay.
So my events will always be written along this horizontal line that follows 0.5.
Mm-hmm.
And if I'm using my mouse correctly, it looks like we would go, my events would be in segment 1 and then end up in segment 3, like right above the division line.
Yep. Okay.
So basically that's how ordering is preserved in Pravega. If we're keying events, then when we come back as a reader, we'll read all of segment 1. Then my account events will be in order, before we pick up segment 3, we'll have exhausted all of segment 1, and then we'll pick up segment 3, and so the reader group that's processing these events, it'll recover all of account 12's events in order.
Okay. I'm also curious. So you mentioned just a second ago that so we're in this diagram, we're showing very even splits, and
right.
And so you're saying though that Pravega does have that option to basically say, oh, okay, maybe in this split, it might have been that we're seeing a lot of hot activity in
right.
0.05 to let's say 0.6. And so you could maybe make segment 2 a little smaller,
right.
so that it's only basically that segment is in charge of all that traffic, and it's not gaining anything from 0.6 to 0.75 here. And that'll be segment 3 in the quieter zone, like you were mentioning. That part is receiving less traffic, receiving less bytes at that point.
Right.
Is that my understanding? Okay,
for sure.
Cool.
Yeah. Or if we look at just the active segments here, let's say segment 4 stays hot, and segment 3 and 6 quiet down, right? 3 and 6 could merge together. And
okay. And stay this one big giant zone, essentially.
Right.
Okay.
Right.
Okay. Got it. That makes a lot of sense.
Yeah, there's quite a bit of variability to it. You can even kind of get into under the covers of the API and specify these segment ranges yourself. So if someone wants to get really creative, you can manually control quite a lot of Pravega.
And basically, if you know your space super well, and you kind of have some way to maybe even predicting or detecting, things beforehand, right. You could start getting those settings. Cool.
Some really special use cases, might benefit. Otherwise, it's there for our automations to leverage. Right.
Got it. So we talk a lot about auto scaling, and I think that's a huge feature that really is kind of one of the more novel features that Pravega is bringing, right? But I also wanted to kind of talk into this other one where it's kind of, Pravega's got this really cool capability now with segments to do transactions. So could you speak a little bit to how transactions can happen, how they can be aborted? Obviously, if you have a transaction, you have this kind of concepts of the same thing with databases, committing and aborting and rolling back. And so, how does segments kind of enable this kind of syntax and capability? What does it look like in a segment level?
Yeah, so it's in Pravega, transactions are literally transient segments. So all of the events that are targeting a transaction will accumulate into these transient segments. If the transaction is aborted, those segments are just discarded and sort of thrown away. If the transaction is committed, then those segments get appended directly onto the active segments of the stream as if they were humongous events.
Okay. And this isn't on by default, I guess. So by default, you're just writing directly to the active segment. But if you enable transactions, there's this kind of almost think about it like a buffer or like a kind of kind of a what's the thing the log, you essentially have kind of a log sitting there. I'm guessing this is bookkeeper, right? So it's essentially, just this pre-commit log, and then you start writing to it, and then essentially the commit triggers like a flush into moving it into the active segment.
Right.
Is that on by default though?
Well, yeah, we have a transaction API. A part of the event API is a transactional writer.
Okay.
And so you begin transactions. Once you've begun a transaction, you get back a little writer object that you actually use to write your events. If you commit that transaction, then those segments merge with the main segments at that time.
And does the transaction context stay with the segment afterwards? And can you roll back and do things like this, or is that?
Yeah, there's transaction. Well, you can introspect transaction status. So,
okay.
So you're actually able to achieve, I guess, exactly once with the use of our transactions, in the sense that really all I have to do is persist my transaction IDs, and then if I have a failure and I'm coming back up, I can can inquire the state of my transaction. If I also know where to pick up where I left off, I can recover those transactions and just emit events into them again and reuse those transactions. If I can't recover in that way, I can cancel that transaction and start over from where that transaction began. So anyway, with some transaction ID persistence and interrogating the status of a transaction, I can confirm whether my transaction is successfully committed or not upon recovery, and I can achieve exactly once semantics on my event system.
That's awesome. And I know that's been like since the beginning of event streams, like really coming to the forefront. That's been one of the bigger challenges is these exactly once semantics.
Right.
There's like, if you just Google exactly once semantics and, you'll get a plethora of blogs written about the difficulty it is to achieve that. So that's very neat. So,
right. Yeah. And we're able to achieve, I guess, especially in the Flink world with their two-phase commit capabilities, we're able to achieve it end-to-end exactly once. So, in the Kafka world, maybe you can get exactly once writing, but then once you're up in, what do they call that? Kafka streams, then you kind of lose your exactly once. And exactly once really allows, I think, the developer to simplify the semantics he's working with.
Yeah.
Otherwise, you're really tied into tracking event IDs or ensuring item potence, and item potence could be difficult to guarantee.
So let's kind of hop into so I wanted to just kind of give us a second to kind of there's another aspect on top of what we've been talking about with this exactly once semantics. We've talked about how segments allow you to auto scale. One cool thing I thought with Pravega architecture is particularly this tiered storage and how essentially Pravega seems to view the stream now as kind of like it's no longer this kind of ephemeral data that just passes through. It's actually a much more it's gearing up for a much longer term storage and trying to treat streams as kind of like essentially just another database. So could you talk a little bit about the the architecture here and kind of how the different tiers of storage kind of work and how you
Sure.
where you go about? Yeah, go ahead.
Well, I mean,
what does it take to run Pravega, right? Like I see here, it's Apache Bookkeeper, so I guess it's written in Java. So like how do you run it?
Yeah, well, Pravega is you can run it a number of ways. We've run it on Mesosphere. You can run it manually. You can do a manual deployment of all the pieces. But Pravega takes the view of kind of being Kubernetes native as well. So our operators are part of the project. They're not hidden away in some proprietary offering. We intend, I guess, Pravega is a project at the Cloud Native Computing Foundation where Kubernetes lives. And so we want to be, right next to Kubernetes, deploying on Kubernetes. So Dell is kind of going all in on Kubernetes. A lot of our systems are being sort of Kubernetesified. Pravega kind of led the way there internally, and so it's you can deploy Pravega any number of ways, but it's I would say Kubernetes is an official supported way to deploy Pravega.
Awesome.
Cool.
Now there's various components. Obviously, we're trying to maintain statelessness and state on the client so that we can achieve horizontal scale. So services are split up in different ways between controller and segment store. We're obviously, as you throw more compute resources at a problem, the more expensive that that solution becomes. So that's the reason for tiered storage is to we want fast acknowledgements so we can achieve the highest throughputs, but ultimately we want to get that data off of local disk and into cloud storage where it's the most affordable.
Yep.
One analogy that I think is helpful to think about these things is just assuming that we're using, let's say, S3 directly. A lot of people will use S3 directly. They'll create all their objects, write to those objects, and then they'll come back around and read those objects. Well, the size of your object under that model increases, if you increase the size of your objects in S3, you're increasing your latency in processing that data. So let's say I'm writing video to S3 in 100 megabyte objects. And I can't read that object until I've fully written, until I've finished writing that object. With Pravega in between, I can be writing the object and immediately reading the object. And then Pravega will handle asynchronously moving that data up into S3 for us. So the reason we want to, I guess, one of the reasons for introducing Pravega is to reduce the latency of these more affordable cloud systems, right? So we can get the affordability of S3 for our data, and we can get the low latency of a typical event stream.
Very cool. Yeah, I like the capability of integrations there, and it seems that another big element of Pravega that you guys are pushing really hard on is these abilities to connect. One of the reasons why you're on here today is because Andrew has written initially the presto-connector, and then Karan, who's also lurking around in the background, is he brought on Trino, and so I do see a huge push for this. Like trying to make sure that you're interoperable with all these different systems, because essentially, it's in the end of the day, engineers are building ecosystems, and you need to the more ability you have to kind of interconnect and make yourself available to other systems, the more successful you'll be as a project. So.
Right. Yeah. I mean, and event exchanges are pretty much predicated on integrations, right? So
yeah, totally.
Yeah.
So and going the step further and trying to really bring the storage capabilities to the forefront of essentially how do we keep this long term if we do want to, because you usually have very limited options in event streams. You're usually like it's much more ephemeral. It's much more okay. We're going to keep this around for so much amount of time, but then if something bad happens, beyond 30 days, and that data's long gone, you can't basically replay it or have any capability to retrieve that data again from the stream. You have to basically totally rely on where that data has materialized downstream.
Yeah, exactly. Yeah, so the more affordable we can make the storage, the longer you can basically keep your data around
and take care of all of your unavoidable, unfortunately, but the mistakes that will happen on pipelines. So
yeah, for sure.
So totally very cool.
There's a ton of reasons, for wanting that kind of replay, right?
Yeah, I mean, testing you could do. I mean, and now you have a new way that you want to push the data out, and so when you say file or object too, this could even go to something as cheap as like Glacier storage, right? Like, do you read
our tiering, what we call long-term storage? There's an API for that. There are a few guarantees you need to provide. But yeah, the destinations or the storages are pluggable. So anyone could come in and plug in anything. Now, kind of like this diagram shows, there's controllers and segment stores. All of these things scale horizontally, and the state's either in Zookeeper or in the client. We keep as little state in Zookeeper as possible to sort of achieve avoiding scaling bottlenecks. But the clients will talk to both the controller. It'll talk to the controller to find out the current state of the stream and where the segment stores are, and then it'll talk directly to the segment stores. And then it's the segment store that is, let's say, retrieving data from S3. So the client won't go directly to S3. The client will request data from a segment store, and then the segment store will go and handle all the retrieval and the buffering and everything for what the clients are asking for. There's an additional layer that this doesn't really show. Oh, does it show that? Segment containers. Yeah, so those little black boxes are segment containers. Pravega does a 2-level batching. So yeah, here in the segment store box, we've got these little black boxes, this line of little black boxes. And those are labeled segment containers. Okay. So we do a type of 2-level batching, or sometimes I call it double buffering, but that's like a graphics term. Anyway, segments are grouped into segment containers. So So this allows us like a second level of batching as we're writing data to the disk. I may have several clients writing to several container or several segments, and those segments may live in a single segment container. So we're not only able to like batch up a single client's data into our write intervals, but we're able to batch up several clients' data into a single segment container. And this allows us to achieve sort of constant rates of throughput, whether we have increasing numbers of segments or increasing numbers of partitions, or whether we have increasing numbers of writers. I don't know if the graph is in here, but we've done performance tests of Kafka and Pulsar where we see them sort of fall over.
Yeah, I unfortunately don't have those.
Right. Well, I just wanted to explain this little thing about segments grouping into segment containers because it provides some of our ability to achieve throughput guarantees.
That's awesome. So, okay, so basically, and here's where I'm going to kind of tap on Andrew a little bit. So, we were just talking a second ago about you guys have these concepts of connectors, and so there's sync connector. Essentially, I think this is something syncing to Pravega. Am I understanding that terminology correct? It seems to kind of flip the because typically you think of a sync, you think of something going out, and so you're talking about from the context of Pravega. I guess sync in this case is syncing into the event system.
Maybe this is written from the view of Pravega.
Okay.
I think you could also what you're talking about might be from the view of a connector or an element. I would
okay, got it.
In GStreamer land, maybe these terms are reversed, and the sync writes to Pravega, and the source generates the data, and then the sync writes it to Pravega. So yeah, maybe this is right. We're just
okay.
It just feels inside out, doesn't it? Yeah,
it does. But I wasn't sure if it was coming from the concept of like maybe external systems or something like that. But either way, so in our case, we are, in our case being Trino, we are viewing basically the Pravega as a source. So we are trying to like essentially what you all have done is like you want to basically have Trino have tables and capabilities to essentially reach out into the metadata sitting in either Apache Zookeeper or in the app in the controllers, and be able to essentially make sense of where all the segments are located. Be it they're sitting in Apache Bookkeeper, or they've been, like you said, kind of stored away on S3 or something like that. And so, it's Trino should essentially be able to, run a query, see it similar to how we have it from the viewpoint of any other kind of table, and query this data. So I'm kind of curious, Andrew, when did you kind of get involved in this? Because you initially wrote this for Presto, and so what was the kind of drive here? Was there an actual use case driving writing this connector, or did you guys just see a lot of use in kind of connecting into Presto/Trino?
Yeah, sure. I guess as you all know, like I hadn't heard of Presto or Trino or anything a year or so back, and then all of a sudden I started hearing it from lots of different places. And just within Dell EMC, like we had customers of some of our cloud storage things talking about Presto, like do you support Presto? So we started looking into it, and it seemed like this cool thing. And at least in my world, like a year and a half ago, it really started to kind of really build up and get super popular. And I'm sure it was before, but that's kind of where it entered sort of our world. And then also at the same time, we're working on Pravega, and we thought it would be and building some analytics things around Pravega. So how can somebody get insight into their data in Pravega, right? So Presto and now Trino, right, seemed like a natural thing to sort of support. There's some other connectors like Flink already for Pravega, so we just kind of looked at like the next step of supporting what people and customers might need.
Yeah, that's also another really interesting one too, and we brought up Flink a couple of times on the show here too. We have Trino is particularly an OLAP system that's trying most of the time to really optimize the reads and read performance. But we all also talk a lot on the show about ingestion, because if your data doesn't ingest fast enough or isn't showing up in the based on your requirements, then Trino becomes very useless very quickly, right? If the data is not there or in a optimal format. And so, we've had different guests on here that have had an array of things, of different solutions, and a lot of them do include either Spark or Flink, usually in tandem with some event store, so some event streaming system, and so I think that the Flink integration is becoming much more popular across the board, and including we have a lot of people that are Iceberg fans that there's also a Flink integration there, and dumping your data into that. So could we just do a quick segue off that, and either Andrew, if you've done work on the Flink, or Derek, if you worked on the Flink connector, any of is that the primary kind of like driver connector that you all use to kind of ingest data, or is there kind of even distribution? Do you do anything with Spark or?
I'm not, so I'll let Derek guess.
Yeah, so the Flink connector was the first connector for Pravega. It was originally like in the Pravega source code. It's since been split out. You can find Flink connectors repository on our GitHub org.
Cool.
So yeah, we support I guess typical Flink jobs and Flink SQL.
Mm-hmm.
I guess Flink SQL is somewhat similar to Trino. We typically see more what do they call continuous queries there, or I think in Trino terms it's called a dynamic table. So dynamic tables can actually be really cool for sort of syncing transform data into Pravega, and then sort of sourcing it back out into additional dynamic tables. You can almost think of these dynamic tables as like CTEs or with statements at the top of your SQL query. So yeah, we're pretty mature in that environment, whether it's running Flink SQL jobs over streams and then producing subsequent streams and then kind of doing that in sequence, or just running traditional Flink jobs in a sort of it's kind of a Spark-like syntax, right, or a Java streams like syntax.
Very cool.
Spark has been added recently, so you can find Spark connectors on our GitHub.
But Flink is I would say, if you were to make a recommendation, if somebody's like, hey, I want to give Pravega a try, you would say for ingestion purposes, Flink makes a lot of sense. It's more mature.
Yeah, I think for certain areas, right? I mean, obviously people are asking us for Spark as well, and I think whether it may be GPU acceleration, maybe Spark is a little more mature there.
Mm-hmm.
So there will obviously be your reasons for choosing one or the other.
Yeah. Fair enough.
I think we started looking at Spark specifically for GPU acceleration.
Okay. Yeah, I think it's a little tangential anyways off the main topic, but I was just kind of curious about that because I know a lot of our listeners are always trying to optimize their ingestion and speeds there. So sorry, Andrew, I didn't mean to totally throw you off the tangent, but so when we're reading from basically from Pravega, and we're pulling through these different segment containers, I assume, and segments. How do we keep track of where we're at in time? Do we essentially do something where we start from the beginning of what's available on the current stream and just start moving along? My mental model is very much based on how Kafka works, and so I think about it as kind of like something moving along in the queue. But does it even work like that, or is it totally different for Pravega?
Yeah, it does. It very much works like that. So when we end up getting a query deep down in the connector, we're going to have a scoped stream that we're going to key off of, right? So the stream is like the encapsulation of all these different segments. The stream is a logical thing, and there's segments underneath, right? So we're asking the controller, right? So we're using the controller APIs.
Oh no.
Somewhere to say, okay, what are the different segments that are in this stream? And we're going to get some list of some of those back, right? And then from there, we're able to sort of iterate, those byte events within a particular segment. And each one of those, as we move along a segment, is a new event and something that's queryable.
Okay.
So, yeah, from the connector, we're asking Pravega controller, like, what's the information, what's the metadata about this stream, what are the segments, and then we kind of go from there.
Okay. And how do you set the schema? Is that determined kind of real time as you like basically just pull from metadata, or is that basically just set? Like you would just point to the Pravega store, it'll know to look at the metadata, the controller essentially, and it'll be able to find that information there.
So there's sort of another step there, right? So Pravega proper itself doesn't really know anything about the data, right? It's just opaque bytes, right? Somebody is just writing bytes to it and it doesn't know or necessarily care. So for us, that schema comes from somewhere else. There's another Pravega project called Schema Registry, which sort of serves this purpose, right? So that's where we get it from, right? So by convention, we're looking for what's called a group in Schema Registry. We'll look there for the schema. If it's there, we'll use it. Else we'll look on local disk on the Trino coordinator for something matching that stream. And that's going to tell us what the schema of the object is.
Oh, very cool.
And then maps into Trino native data types, basically.
And then we map it into Trino, right? And you don't, right? So that's why we have Pravega Schema Registry, local disk, defining a local disk. And there's no reason it couldn't be something else, right? I mean, that part's pluggable, but that's what we have now. Yeah.
Very cool. Very, very cool. Okay.
So in the end, when the stream comes, you can query it with SQL and you can get different types and fields and everything, like just in a normal.
Yeah, exactly. And perhaps I should have started with this too. So we have, the idea of a stream, right? So like, how do we map to Trino? So in addition to streams are within a scope. So scope in Pravega is basically, you can think of it as a namespace. And within that namespace, you have streams, right? So we kind of map that onto Trino, where a scope will be your schema in your catalog. And then underneath, your Trino schema are the streams that are in that scope, right? So if you were to, show tables from Pravega catalog and, XYZ scope, right, you would see a list of streams that were in Pravega, and you can query it from there as individual tables.
Oh, cool.
Very, very cool. So we're gonna basically have to move on from this, but this is super, super cool. I really I always enjoy, especially because it's not really like intuitive all the time how you would map something, like a stream directly into a batch system that is Trino. And to be clear, that's scoped or namespace that Andrew's talking about. That's the kind of piece that makes this not a true streaming query that you're running, right? You're not running anything similar like Flink, where you're actually able to run this kind of continuous query. It's not doing anything like any magic like that, right, Andrew?
Yeah, no, it's not. I mean, it's like very much just like a typical database, right? It means we're just reading, from one end to the other. So yeah, nothing continuous. Yeah.
Yeah. Okay. Awesome. Last thing I wanted to kind of get to covering before we hop into the next one, hop into the next segment. So I have this kind of this comparison chart that, let me click on here and get a little zoom in. This comparison chart that kind of just does exactly what I think a lot of our users like to see, is just tell us what exists on all of them, tell us what doesn't exist, and this is the one that you all have on Pravega.io. So I just basically copied it from there and just put it into our notes format. Could you kind of using this as kind of like the full list of what we've even gone over today? What's the ultimate goal with Pravega that really drove the basically building something outside of what currently exists as the well-known solutions today as Kafka and Pulsar? And this, I guess, one will probably just go back to Derek. If you have any kind of overarching statements or kind of final statements to summarize this.
Sure. Yeah. Well, I mean, obviously Dell has a lot of experience in very large systems. So Dell has used Kafka pretty extensively and other technologies as well. So I think from our experience there, we've sort of wanted something more, whether that's to improve the lives of the developers themselves, or even to improve the lives of the system administrators and the operations staff.
Yeah.
On either side, as your sort of as your abstractions deviate from their concerns, you sort of make their lives more difficult. So, I mean, we've talked about some of this stuff already, but obviously all the systems support transactions, all the systems support event streams. And that's kind of where, Pravega starts to try to differentiate itself with long-term retention. That's the long-term storage, the two-tier storage we talked about earlier.
Yeah.
Asynchronous, moving the data asynchronously from the stream cache and the write-ahead log or the durable log into cloud storage. So that we sort of led the way there. Pulsar has a full implementation in their open source now. So Pulsar has that. We could maybe do like a half check here for Kafka. Their open source implementation is coming along. Confluent is previewing tiered storage in the proprietary offering. And I checked recently, their interfaces have been committed. Their in-memory long-term driver has been committed. They've thrown away or pulled out their HDFS and S3 open source drivers. So something will happen there. But code is slowly being merged, but the production code is not there yet.
Okay.
Another thing we're very concerned about at Dell, you see it in a lot of our storage products, but durable by default. Like Dell does not like to lose data. So being durable by default was really key for us.
Yeah.
Pulsar is also durable by default. I've seen a KEP to change Kafka defaults so that it'll be durable by default. So maybe soon we'll see Kafka become durable by default. You can certainly change a few toggles and make it durable. Autoscaling is, I think, our big thing. That's a big sell for the operations team and the system administrators. You don't have to replay your entire stream into your scaled cluster like you do with other systems. Other systems, you've got to basically like reshard your data after you've scaled.
Yeah.
We try to avoid that. There may be reasons to do that in Pravega with certain streams. Eventually we are able to like balance, segments across segment containers and other things as you add nodes. So there's different levels to this auto scaling.
Yeah.
Ingestion of large data. This is, really speaking to our byte stream API. If you don't use the event API and you use our byte stream API with exclusive writers, you can basically do video streams into Pravega. You can read those streams back and do video analytics. So this is something that Kafka and Pulsar do, but you chunk up the data yourself and you pack it in a message, and then on the other end you pull the data back out of messages. So it's quite a bit of heavy lifting for the developer in those systems. Efficient at high partition counts, also efficient at high writer counts. So this is that segment to segment container sort of two-layer batching that I talked about earlier allows us to achieve consistent throughput rates where we can show Kafka and Pulsar sort of fall over as we increase these scale factors. And then consistent state replication, that refers to this is used in our transactions, but basically you have conditional appends on our segments. So we can do basically a state synchronizers on top of that. It's very similar to what do you call it? Monotonic versioning, I guess, where it's like commit this change if the sequence number is still 3, right? Got it. So off of that capability is built into the segments. So off of that we can, build state synchronizers, do the state synchronizer pattern. And then on top of state synchronizers and other things, we build these key value tables. So inside of the streams, you can maintain key value tables. All the readers and writers of the key value tables are guaranteed to like stay in lockstep with each other as they work with this or writing data there. So this
replaces HBase.
Yeah, maybe. We're in the second beta of key value tables, so we're still sort of tuning things, but we invite people to check it out. It is really cool.
Isn't it?
Our Akka connector has check out our YouTube for the Akka connector demo, and you'll see some really cool uses of like keeping counters and key value tables while processing data coming through streams.
Nice.
Yep.
Awesome. Well, I think that's awesome. I mean, we definitely went really into
quite
the
long,
weeds there, and quite long. But I tell you what, I think it was really useful. Like, there's just a lot to Pravega, and I think at this point, it's time for people heard more about it and understood it a little bit better. So hopefully this is a good resource for all of our listeners, and have them consider Pravega for sure.
Yeah, absolutely. It was a great conversation.
With that, let's go ahead and give Andrew a little time to shine and cover into the demo of the week. All right, Andrew, show us your best stuff. Let's see. So this is going to be showing us a little bit about the Trino connector and basically how it's all set up. So tell us what's happening now.
Yeah, so I'm just gonna bring up our stack, and it takes a minute or two. So I'm just gonna do that to start to get that underway before I just kind of show you just briefly discuss kind of what I have to show you.
Sure.
So in our code, right, and on GitHub, we have our Trino and Presto connectors, right? So right now these are separate, right? And obviously we're focusing on Trino, and within there we have a getting started sort of sample, right? And at the end of this, basically what we're doing is setting up a full Pravega stack, and we're just running it locally on this VM here. We're gonna insert some data and query it using Trino.
Awesome.
And alongside of that, we have a little demo Java application that does the ingestion of the data. And I was going to also kind of, after running this, kind of step through a little bit of this code, because not only does it explain a couple of things on the Trino side, I think it will show some of what of you actually using Pravega on as a client, right? And some of the stuff that that Derek has spoken about.
Okay.
Yeah, so quickly, just going back to the CLI, right? So you can see that we have a number of services. So we have HDFS right now is going to be our long-term storage, and that's just local disk. And we have Zookeeper, all our bookkeepers. We have a Pravega instance on the coordinator and one for the segment store. We have this thing called schema registry, which we just spoke about. And then this other image, which is Trino itself, right? So maybe the first thing to sort of discuss is, right, so I mentioned that we have these connectors in our own code base, right? So we're not in the main line. So we basically just have the first step, which I've already done because it's not that exciting to look at, is we're basically just inserting ourselves into, we're just creating an image, right, with our configuration and our plugin running it. All right, so that's what this is here, and then we start that up. So now that's whatever's in the Trino base image plus our plugin. So I'm going to go ahead and run the demo. It's going to insert some things, and I'll go ahead and talk about it. And this should start going. All right, so this is going to start ingesting some data. So I'm going to go ahead to the sample app while this runs. And the first thing I want to show is basically ingesting data into.
Hey, can you bump up your font a little bit?
Yeah. Yeah, if somebody wants to shout out how to do that real quickly while I'm struggling through it.
I think a pitch zoom, or I don't know if like Control Plus or.
I do. I don't have a Windows, unfortunately. So
this is on Linux.
On Linux.
Well, my apologies.
Easiest might be to change screen resolution altogether.
Real sorry about this. Is it like?
Oh, no problem. In IntelliJ, I always pinch zoom, but I don't know what kind of. I don't know if you have a touchpad there.
No.
Well, let's just run with this, I guess.
Yeah, I'd say we just, if you could just run through it instead of going through all of the the stuff in the GitHub or any of the code too extensively, we can just kind of explain through the because I can see your console pretty well.
Yeah. All right. So what this did was just wrote to 3 different streams within the same scope. Demo is our scope. Inventory is a stream. We just wrote 1,000 sample events. It's all just dummy data, right? This first one happens to use Avro, and you can see the schema. The second one is sensor stream, and that's a JSON schema. And then this last one, there is no schema dumps, right? So just to quickly describe what's happening here, which I would have shown in the code, was for this first stream is we're writing the data using schema registry provided client wrappers, in which case we're just using their serializers provided by the Pravega schema registry. It's taking care of serializing the data for us and managing our schema in schema registry itself, right? So we're not doing anything with the schema. That's kind of happening automatically. The second case is I'm writing events and I'm managing the schema on my own, but I'm still storing it in schema registry. So I'm just writing events, and then out of band, I'm sort of adding this schema to schema registry, and that just happened where it's stored. And then this last one, right, is the third way in which I have not put the schema anywhere. It's just on local disk, and that's inserted into the image. Right, so we have our schema definition here, and then this ends up on the Trino coordinator, where it can be, query, where we can build the actual stream definition from.
Very cool.
So now I'll go ahead and fire up the CLI, and we'll just take a quick look at what that looks like. So this is just the Trino CLI right. So just to quickly show that, yes, we do have Pravega running. And forgive my slow, sluggish single node VM here. Right, so when we do, again, so now when we're showing schemas from Pravega, right, we've just gone and asked Pravega what are the scopes, right? And now when we do show tables within this schema, right, we're asking what are the streams that are within the demo scope, right? We should see these 3. Right, so again, these first 2, inventory and sensor, we're going to actually reach out to schema registry and see if they have anything for something called demo.inventory. If they do, we'll use it. Same thing with sensors, and then transactions, that doesn't exist. So again, we're grabbing this right from the local disk on the coordinator to build the definition. As you can see, we've mapped that Avro schema that was dumped to screen. We've mapped that to the given Trino types.
That's awesome.
So it just exposes that in the information schema, and then any CLI or whatever other tool can understand all that data, right?
Right.
Consume it, yeah.
And then this is just dummy data in here, so not particularly meaningful, but just to show that it all works. And
Andrew, that's all we deal with on this show is dummy data. We need data for dummy.
Yeah, and you can do
specifically
any constraints and whatever that's supported by Trino and full SQL. It works.
Awesome.
Yeah.
So we'll add the links into this too, by the way, because I think the more valuable thing to take away from this too is that you can you could just go ahead, jump into this and play around with it. And Andrew, if you want me to hand me the links after the show, I can actually kind of point people to a couple of those areas of the code that you wanted me to point out, or that you were going to go point out.
That'd be great, because I do encourage you to look at the actual code. There's only a couple class files, and again, it kind of shows how you ingest into Pravega, right? So nothing to do with Trino. And then how we use Trino, how we use schema registry, and how we do things. And it should be a good primer to get you started on both things.
Very cool. Really exciting stuff, especially from the standpoint like we're pretty obsessed with schemas and making sure that things are aligning, especially now if we're thinking of ourselves in these positions like data mesh and trying to align things across organizations. It's a huge piece to our technology and what we think about a lot. So very, very cool. I'm really, really super excited that you did this, and we're actually going to be talking about this the PR that pulled this in here in just a second. So before we hop on to that, did you want to mention anything else, Andrew, before we move along?
Just quickly to follow on to schema. So just so what we support JSON, Avro, protobuf, protocol buffers, and there's standard like delimited field like CSV or something similar. The reason we started with those is because other than being popular, that's what our Pravega schema registry supports out of the box. We could use anything. It's just a matter of looking up the schema and translating it, right? So that's what we started with, and of course, looking to grow support of other formats as well.
Awesome, love that. Yeah, I mean that's always super, super helpful too, and you don't have to custom code all that stuff yourself.
Yeah.
So, all right. Well, with that, let's go on to the PR of the week. Per usual, I'm not going to be able to make it to the spot in my screen in time, but now we're here. So this week's PR of the week is actually not in TrinoDB Trino. Let me go ahead and bring up Karan, hey, welcome to the show. He's been hanging out in the back, patiently waiting for me to give him his accolades.
Hey guys, hi. How are you doing?
Doing well. So Andrew, you created the Presto connector, and then Karan, obviously we had the rebranding back in January, and then things as unfortunate outside of our ability to control, we had to basically do a very quick change into some of the requirements for the APIs. Everything basically that was saying Presto had to move to Trino, and that broke a couple things and basically caused it to where you have to change some of the things that that JDBCs and all these things that interact with our system, right? HTTP calls as well. So you then kind of took the existing Presto code and split this off into Trino into this PR 49 that we're pulling up here. So is that correct? Yeah.
That's correct. Yes.
So what was the experience like? I just from a understanding of like what's what the experience is like to migrate from something that works for Presto and now something that will work for Trino. Was it a pretty straightforward process, or was there a lot of difficulties in kind of making that migration?
Yep, that's a good question. So there weren't many difficulties in terms of the actual logical changes and code changes, but yes, it took some amount of work to kind of migrate from a project which does or rather organizes things in a different way as compared to Trino, where things are organized in a very different way, especially when you're trying to access SPIs and stuff. There have been some changes in the table layouts and stuff like that on the Trino side. So it took some amount of code changes, major amount of organizational changes in terms of code. But I wouldn't call it either straightforward or too difficult. It was just like, on an average, like about a week's worth of work, and boom, we had it.
Do you think the biggest part of it? So one thing for those that haven't looked through any of when we did the change on Trino, there was one other change that David Phillips had proposed a while back, and this was kind of our opportunity. Our connectors and everything if you look at the Presto project too now, like the connectors are starting to build up, and it's making like the artifacts list in there kind of get super, super long. So they for a long time wanted to kind of modularize that. And so we looked at the rebrand as kind of this opportunity. Well, everything's breaking anyways, right? So we might as well go ahead and do that. And so was that the primary, I guess, kind of additional layer of complexity in the migration, or was there other pieces outside of that?
That's right. Yeah, that's exactly right. So the modularity which comes along with Trino as they moved away from the Presto project initially was the one where the major difficulty had arisen. Because that was something different as compared to what we were doing with the Presto connector. Yeah. You guys had put everything in the plugins, whereas the Presto had like all the connectors laying out, and then various like packages naming and stuff like that. Certain dependencies which had changed at some places which were supposed to be fixed. So yeah, those were the major difficulties that were
Okay.
there while we were migrating from presto.
Good to know. And it's always good to think about that too, especially as other people like that maintain internal projects that are thinking about still, we know that the reality is that not everybody has upgraded yet, and they're still thinking about when do we move to Trino and some of the difficulties. We talked about it too with LinkedIn a while back and their migration journey from Presto to Trino. So it's always good to kind of bring those kind of woes up as well, and so that everybody kind of knows what to expect and gets a good sense out of that. So so thank you so much for bringing this in, and we're really excited to kind of have this connector now between Pravega and Trino, and it's it's gonna yet again kind of grow exposure on both sides of the field, and I'm excited to see as Pravega starts to build out and become more and more common, our users be able to kind of take advantage of this. So thank you so much for putting this PR together and doing all this work.
Sure, thanks, Brian.
Awesome. All right. Well, with that, let's move on to the question of the week. Okay. And I'm going to do the last little bit. So this question is a little bit self-serving, but it is going to be serving a good purpose. It's all for a good cause. So this question of the week is asking kind of what's the point of Trino Forum and what's its relationship to Trino Slack? So I have been working on Trino Forum, and it's actually, so let me pull up the, I'm trying to click on this on the stream, not on the actual page. So this question actually came up. I pitched this idea, Trino Forum. We have this thing called Trino Slack, and by the way, if you have not joined the Trino Slack, there's a link in the show notes to do so. And so we have a lot of our kind of tribal knowledge and a lot of really kind of ad hoc, informal discussion around feature changes and things like that happen in Slack. But one of the things that was really difficult is, kind of day to day, we get a lot of newcomers that are coming into the project to Trino, and they're asking a lot of, very similar questions. And the reason why they're asking these questions is because they can't find the answers to begin with. And Slack, unfortunately, does not, kind of lend itself to being searchable by Google crawlers and things like that. It's actually a very private platform, and it's really good for ad hoc discussions. But then when you want to take those discussions and kind of condense it into the actual kind of digestible, not documentation, but kind of, pre-documentation, as I like to think of it, you don't really have the ability to do that. And so I initially kind of set out on this project to kind of say, hey, why don't we put together, an FAQ on Trino? And unfortunately, this, kind of has a lot of, scalability issues, especially, as I'm only one person and I would be doing a lot of this in the earlier days. But then as we even scaled up maybe a team in Starburst or something, or having, some community effort that scales up, it's not going to be something that would be like everybody can just join. And so we started looking at a lot of other community or other projects that started to use forums. And so we're now looking into adding this Trino Forum, and it's basically going to be a complement to Trino Slack. It takes a lot of even conversations that have happened already in Trino Slack and mostly just kind of ports them over. Takes maybe the 3 different locations that they happen in Slack, or the long huge thread, and tries to condense that information down rather than this kind of back and forth conversation, to basically just give you straightforward answers. If there's questions that get re-asked, we are going to kind of try to, similarly to Stack Overflow, try to just mark these as duplicates and try to make sure that it's a really condensed web of information that maybe at some point, as we get more and more of it, could be good content to lend itself to documentation. And but kind of in the interim, fill this kind of gap where especially as new features roll out and things like that, or changes happen, you get to see it real time, and community efforts will bring up a lot of this information. And the best part is it gets all indexed by a Google crawler somehow, and you can now search all this information. And so we really don't see this as kind of like a Slack replacement in any way, shape, or form. Slack is really good for when you have a question, you don't know the answer to it, and you need to get a little bit of dialogue to, let's say, develop a feature or something like that. But we want this to kind of really fill the spot of common questions that could ask, basically a living FAQ, and essentially be this nice resource where people can do this. And it's all this one versus the things like Trino Community Broadcast and other items that we have. This is, run and managed by Starburst, but we do welcome community members to come in, and essentially, the more active you are on this forum, you get more kind of management capabilities and moderation capabilities, just like any other forum. And hopefully at one point, the goal is that we don't really manage this as much anymore, and it's primarily community driven. So we are really excited about this. I pitched this to a couple of people earlier on, and this was their questions that I got back was, confusion between why we're going to use, discourse forum versus, we already have Slack. And so I wanted to be very clear as to what the point is. And so this is now kind of, getting up, active and hopping. I've talked to a couple community members that are already asking questions and already kind of getting some answers in through there. I'm also super active in there, trying to port over a lot of the stuff that a lot of tribal knowledge that we've had kind of sitting in Slack, and getting those very, very high level common questions brought out into this Trino Q&A section. And we'll also, of course, have a community section where we try to condense very useful resources and and like blogs and things like that we find on the internet that are super useful. So hopefully, definitely take advantage of this if you are, especially a newcomer, intermediate person. But even if you're the advanced person, we really need you. And at some point, we are going to be looking into setting up a prize to give out Commander Bun Bun plushies. Commander Bun Bun, for those of you who don't know, we have this little mascot bunny here. Commander Bun Bun plushies are made now. They're in transit. And so once they are here, we will be setting up prizes to basically answer a certain number of questions or ask a certain number of questions. And we'll be sending the first 20 to answer. I think it's we put somewhere in the range of like 5 questions, or answering 5 questions. Once you've done 5 things essentially on Trino Forum, then we'll be sending the first 20 a plushie. So really excited about that, and stay tuned for that. And with that, I think that pretty much wraps up the show. So I want to again say a huge thank you to the fine folks from Dell Labs, but the Pravega community in reality. Thank you, Derek. Thank you, Karan. Thank you, Andrew. Also, thanks to Flavio and everybody else that works on the Pravega community. It's a really, really, really cool, badass project, and really excited to play around with it more and do a couple more of these probably moving on in the future. So again, thanks everyone.
Thank you, Brian.
Thanks. You. Yeah, very great.
Awesome. Manfred, before we hop off, anything else you want to add, or anything I missed?
Well, make sure you register for the Trino Summit next week and join us there.
Yep. Awesome. Well, see you all then next week at the Trino Summit. Talk to you later.